What's up, everyone? I'm back with hopefully a quick video. This is gonna be a home brewed show, not in the lab today. I'm feeling a little bit under the weather, um, but I've got this HP 8116A function generator here. I actually did a video not maybe over a year ago on trying to repair one of these, and unfortunately it ended up being one of the ASICs, the hybrid chips, that was causing this error. Um, I ended up buying a couple of those chips on eBay to repair it. That was actually on a separate one. This one worked fine, but it has a horrendously loud fan, which I will showcase now. Listen to the sound of that. It's quite loud. I don't know if the video is capturing how loud it is, but it's very loud. I tried relubricating it, didn't work. And so what I'd like to do is just replace it with one of these. Same size, I think it's 60 by 60 millimeters. I can put the part number in the description. And I think this is going to work. Now, the fan that's in these, and we'll tear it down and I'll show you, it does have its own driver module. But it does take 12 volts, that module. This is a 12 volt fan that we've got here, and so it should be fairly easy to swap out. So that's what we're going to do. Alright, so first we're just going to start by removing this back screw. And this guy does have some, I believe, some Torx style screws as well, so we're going to need those removed. We're going to pop these off. Another screw on the bottom to release the bottom cover. Okay, now this piece is removed, this side frame. And we're also going to want to remove this too, because there are two screws on this heatsink that we need to remove so that we can free up the fan. It's really a pain the way they assembled this. I feel like they could have made this much easier somehow, but yeah. Alright, so this is where things start to get a bit annoying. This piece is now free, so you're going to have two long screws that go in the top, and then on the bottom there are three littler screws that hold this thing in place. This is what the fan is attached to, and this piece, this is what makes this so annoying. So there are two screws, yeah, you can see one of them there, just about. I just caught it. Yeah, yep, yeah. They're right in this heatsink, which then attached to this black um, subframe. You can kind of see that moving here. So because of this, you can't. It really makes taking this thing apart a pain in the ass. So we need to remove these two screws to remove this big heatsink, so that way we can finagle this guy out of here. You're not going to be able to get it out without doing that. Alright, so that's the heatsink removed, so you can see, and that's where it attaches to this bar, to this frame right here that can now slide out. You know, I really don't know why they did this way, but because again, it really makes it quite annoying to disassemble this guy. But now, this guy's totally free, and you just disconnect these leads. Okay. Just remember where they go. There you go. And I'm probably just going to save these terminals, and just splice the wiring with the new fan. And this is the module that drives this fan. There's some circuitry in there, some motor driving circuitry. We're going to discard that. It's just going to be powered directly by the 12 volts. Because this is just a 2-wire fan that we've got to replace it. So we just need to unscrew this fan from the unit and pop in the new one. Well, it looks like we're going to have to bust out the soldering iron earlier than I thought, because to remove this guy, the wiring needs to be removed from the fan so that this will slide through, and we can release the fan from the subframe. So we'll have to do that first. Well, it looks like one wire got disconnected already, got ripped out. Alright. Fan is free. Now, I'm going to remove this motor driver module. We don't need it anymore, at least we hope we won't. And we will, though, salvage those these two terminals. I mean, obviously, it's not like these are hard to get or anything, but I don't have anything like that on hand, especially at home. So I am just going to cut them and splice them to the new fan. That's one. That's two. Feels nice and strong. Give it a good tug. And unfortunately, I don't have the heat shrink that I have is just too big. I might try it anyway, but might just have to use electrical tape. Should feed it through. The frame first, otherwise it's not going to fit. That would definitely be something I would do. There we go. That should be good. Alright, fan is in place. Yes. And so the airflow is moving this way, which I think should be okay. It's going to be pulling air over that heatsink, so that should work. Yeah, it's not ideal. Definitely not ideal, but it'll have to work for this. All right, now time to reassemble it. So this was the one that had the cracked resistor. This must be a current limiting resistor for the fan. Possibly. The original had a big crack down the middle of it, which I showed in the video that I did. I was watching that video, and some of my early videos, even now, I tend to talk a bit too much. I'm trying to get better at that, so I do appreciate everyone who's stuck through watching this channel. Also, my knowledge of electronics was minimal, and it's gotten a little bit better. So, you know, this was never meant to be how-to video uh, uh, channel, and it still isn't. You know, just sharing what personal projects I'm working on. So, you know, I appreciate those who stuck through it. But let's put this thing back together. Well, getting the big heatsink on with the motor driver module out, no longer there, it does make it a little easier to get it back on, but it's still nevertheless a pain. But now that we've got it in, got the fan connected, let's power it on, see what happens, see if it blows up. It's actually still really, oh, I see I think the wiring is hitting it. Yep, I was like, why is that's brand new? It's hitting the, okay. I just gotta fix up the wiring a little bit because that's what it's just brushing up against it. That sounds much better. And I'll clean the wiring up a little bit. I should have made it a little shorter, honestly, but that is so much quieter, and it works great. So far, so good. Let's finish the assembly, and we'll be done with this. And yeah, I never replaced that battery. Again, if you watch the repair videos on these, now the batteries on these, they don't, I'm almost positive they don't save any cal constants because all the calibration is done via trim pots. Really, I believe the only thing that you're losing with the battery missing is it's not going to save the settings on the, the digital settings on the front panel. So it'll default to whatever the default setting is. So you do lose that functionality, but that's really not a huge deal for me. Maybe someday I'll find something, either a suitable battery or a supercapacitor, something to replace that. But really, I mean, you can really see the damage that was done by that battery leaking all over. Yeah. Alright, so I figured before we wrapped up here, go over how the motor was being controlled in the original fan, because it's actually kind of interesting. In that, well, in that box, this gray box, is the circuit board for the driver circuit, and you can see that you've got some transistors, you've got some resistors, some capacitors. It's all discrete. There's no motor controller IC or something generating a PWM signal. You know, it almost kind of looks like this is some sort of inverter circuit, right? With the 6 transistors, a 3-phase inverter circuit. This is actually, or at least it appears to be, what's known as a ring oscillator. And these are astable multi-vibrator circuits. And what you have here, you can have these in a variety of different kinds. This type is what's known as a relaxation ring oscillator, because it's using a network of capacitors and resistors to generate the frequency, by these transistors switching on and off, and the capacitors charging and discharging, and also with the resistors, you've got this RC type circuit that's going to be setting the oscillator frequency. And then you can see here we've got a diode there that's probably preventing, for the back EMF from the motor, so to protect the the voltage rails on the main board of the pulse generator. And then this is, right now we're just probing 2 of the windings on the motor, and you've got this really interesting waveform being displayed. They are 120 degrees out of phase, and what's interesting about that is the phase, that shift, is going to be set by the number of inverters that you have in this ring oscillator. And so it's I believe 2 pi divided by n, where n equals the number of inverters. So for example, if there was 5 inverters in here, that would be 2 pi n divided by 2 pi divided by 5, and so you would get an even smaller shift, phase shift. Another thing that's interesting about these ring oscillators is they only work if you have an odd number of oscillators. And so, if you think about an inverter where you have, say, you just talking straight in digital logic, you would have input of 1, then a 0, then that other oscillator is going to input a output of 1, and then that one is going to, the third one is going to output a 0. And so if you had 4, you would be getting the same output as the input, and that wouldn't work for this circuit. So just a little neat thing to check out before we wrap up. Well, that is a wrap on the fan replacement of the HP 8116A function generator, pulse generator. Everything works. Not gonna hook it up because I would be surprised if anything was wrong. But no errors. Sounds quiet. It's good to go. Yeah, I mean, these things I really like these. They're so easy to use, but they do have an Achilles heel, including that loud fan, but also the ASICs, those hybrid ICs that do the shaping. The voltage controlled oscillator, I think, is one of them too. There's 3 of them, and I forget exactly what they do, but those go bad, and then once they go bad, there's really nothing else you can do but replace them. And you can still find them online, but you really got to weigh that, because they can, when I was looking for them, they were most of them were pretty pricey. Yeah, I hope you guys found this interesting. If you have any feedback, leave it in the comments, and I'll catch you at the next repair. All right, have a good weekend.